Hello everyone. Today let us discuss how to solve the problems on the topic of LCR series circuit. This comes under AC, that is alternating current. So here in alternating current we have many topics: AC through a pure resistor, AC through a pure capacitor, AC through a pure inductor, and then last we have AC through a pure AC through a LCR circuit. That is, LCR circuit means we have series circuit, that is inductance, capacitance and resistance, three are connected in series to a AC source. So let us see what are the numericals what we have to solve. Here I have written, and to solve these numericals let us see what all the formulas we can use. So let us first rewrite whatever that is there, the numericals formulas for these problems. So let's take, for example, if you want to find the impedance of the circuit, the impedance is given by the letter Z. Z is equal to ERMS by IRMS, that is equal to under root R square plus XL minus XC whole square. That is also can be written as under root R square. XL means omega L, XC means 1 by omega C whole square. So this is one formula which you have to remember to solve these numericals. Let's see the other formulas. Another formula which you have to remember is the phase difference between voltage and current, let it be phi, then tan phi is equal to XL minus XC by R, or that can also be written as cos phi is equal to R by Z, where R is the resistance and Z is the impedance. And what else the formulas are here? The resonance is one of the most important topic, that is when capacitive reactance is equal to inductive reactance, we write XL is equal to XC. When XL is equal to XC, we have maximum current flows through the circuit. When maximum current flows through the circuit, we get the impedance Z is equal to R. At resonance, the condition is XL is equal to XC. Then at the resonance, the resonant frequency FR is given by 1 by 2 pi under root LC. This is the most important formula which you have to remember, because it is most of the numericals for competitive exams are asked based on this formula. Next, what else is remaining is we have another one is Q factor in this topic. The Q factor is equal to omega R by omega 2 minus omega 1, where omega R is the resonant angular frequency. Omega 1 and omega 2 are the two frequencies which are left and right side of the resonant frequency, that's called as the bandwidth. Then that is also equal to omega R L by R, that is resistance, that is also equal to 1 by R under root L by C, and that is also equal because omega L is equal to 1 by omega C. You can also write it as 1 by omega R C R. This also you can write, because at resonance omega L is equal to 1 by omega C. So in place of omega L you can write omega RC. So these are the various formulas which are there in the LCR series circuit when connected to the AC current. And this is our main formulas which we have to use to solve the problems. Okay, without wasting much time, let's continue with our numericals. The first numerical I am taking is a resistor of 12 ohms and a capacitor of reactance. So this is the one I am taking. A resistor of 12 ohms and a capacitor of reactance 14 ohms and a pure inductor of inductance 0.1 Henry are joined in series and placed across a 200 volt 50 Hz AC supply. Calculate the current in the circuit, the phase angle between the current and voltage. Take pi is equal to 3 for purpose of calculation. So this is the problem which they have given. So here they have given a resistor. Whenever that problem is given, first you have to think what is given in the problem. As I told you in my earlier videos, I already told you, whenever we are going to do some numericals in a particular topic, first you should know all these formulas related to that topic. You should know them by heart. If you don't know by heart, you have to learn them. Many students think numericals are difficult, but it's not difficult. It's very easy if you know the formulas. And if you face difficulty in learning the formulas, just by heart them. And after learning them, you write them 5 times. After writing 5 times, looking into the book, then close the book, again write them for 5 times. And then definitely you will learn the formulas. This is the best way to learn the formulas. If you don't know the formulas, again close the book, again write them 5 times. Over. By the time definitely you will learn. So nothing is impossible and nothing is difficult. In fact, numericals are easy, very easy if you know the concept, if you know the theory part. So now this is the problem which we are doing now. The first problem, a resistor of 12 ohms, capacitor of reactance 14 ohms, but inductor they did not give the value of the reactance. They gave inductance value 0.1 Henry. They are all connected in series and the voltage is 200 volts at 50 Hz AC supply. Now what we have to do, we have to calculate the current in the circuit and then the phase angle between the current and the voltage. They only told take pi is equal to 3 because calculations will be complicated. So now let's start this one. Let's go with our first problem solution. So let us see what all is given in the problem. They have given resistance as 12 ohms and then capacitive reactance, that is Xc is equal to 14 ohms, but they did not give inductive reactance, but they gave L value as 0.1 Henry. 0.1 Henry, you can see this is the problem. 0.1 Henry here they have given, and then they are connected in series. All of them are connected in series. Then after that, what else they have given is, that is E effective, that is voltage, E effective, that is equal to 200 volts and the frequency is equal to 50 Hz. Now let's calculate the impedance. Z is equal to under root R square plus XL minus XC whole square. This formula is here. Here I have written. You can see here. You can see here I have taken this formula. You can see this. This is the formula which we are using. Okay. So just to make you to understand, I am putting in the box. Now I have removed the box. This is the first formula we are writing and we are using. And then after that, using that formula, let's calculate now and then substitute the values. Because we don't know the value of XL, first let us take XL as XL value because we need it. XL is equal to omega L, that is omega means 2 pi f, L that is 2 into, they only told us to take a pi as 3, f is 50 hertz and L is 0.1. And then once you simplify, you will get 30 ohms. Now you got the value of XL. So once you know all these values, let us substitute in this formula. And we get Z is equal to under root R square, that is 12 square plus XL. Just now we calculated, which is 30, and XC they only give in the problem as 14 whole square. That comes around under root we will get, that is 12 square plus 16 square, that will come around under root 144. 12 12s are 144 plus 16 into 16 256, that is under root 400, which is 20 ohms. So the final answer Z is equal to 20 ohms. So we got one answer, that is impedance of the circuit. They did not ask impedance. You may get doubt why we are calculating impedance. Because to calculate the current, we need impedance. To calculate the current, we need impedance. That means now we will calculate the current now. Current I is equal to, that is I effective, that is I is equal to E effective divided by Z, that is equal to 200, which is given in the problem. Z we calculated, we got 20, therefore 10 amps. It is 10 amps. Now after that, first one is solved. Then let's see what they have asked. First they asked calculate the current in the circuit. Second, they asked the phase angle between the current and voltage. Calculate the current is over now, we have done. Now phase angle between voltage and current we have to do. So phase angle between voltage and current, for that we have taken this formula. That is tan phi is equal to XL minus XC divided by R. So this is the formula which we will be using. So let us use that formula to calculate the phase difference. That is tan phi is equal to XL minus XC by R, that is 30 minus 14 by 12, that is 16 by 12, that is equal to 4 4s are 16 and 4 3s 4 by 3, which is 1.333. Therefore, as per the trigonometry, phi is equal to tan inverse 1.333. Then you may get doubt how to find 1.333. To find the angles, we have some logarithmic books or Clerk's tables. Some people call them as Clerk's tables and some people call them as the logarithmic tables. Or sometimes in the question itself they will provide the value of tan inverse 1.333. So depending upon in the examination hall, if they give the tables, you can find from them. You can go to the natural tangents and you can search for that. If they don't give, they must have given in the question itself. Then finally you will get to phi is equal to 53.1 degrees. If you can see it through that book or take the help of the clerk's tables. So this is the first problem which we have solved. So now let's go for our second problem without wasting much time. So now I am taking this second problem. In an LCR circuit, L is equal to 5 Henry, C is equal to 80 microfarad, R is equal to 40 ohms. They are connected, they are all connected to a variable frequency of 240 volt source. Earlier they have given a frequency of 50 hertz. Here they did not give frequency, they said variable frequency. That means frequency is changing. Calculate the angular frequency of the source which drives the circuit at resonance. At resonance, what is the frequency? You have to calculate first. Second, calculate the current at resonant frequency. Third, the RMS potential drop across the capacitor at resonance. So now this is the problem which they have given. So we have to do that. First thing, angular frequency at resonance they have given. So angular frequency at resonance, we have the formula. Just now we have written here. This is the formula which I have put it in the rectangular box. So this is the formula which I have put in the rectangular box. Fr is equal to 1 by 2 pi under root LC, that is normal frequency. If you want angular frequency, it is simple. You can send 2 pi to that side. You will get 2 pi Fr is equal to 1 by root LC. Therefore, 2 pi F is nothing but omega R is equal to 1 by under root LC. So from here you will get this formula. So they asked us angular frequency. So we will calculate angular frequency only, that is omega R is equal to 1 by root LC. So let's first take whatever that given data. Let's start with our given data. So given data is VRMS is equal to 240 volts. Inductance is equal to L is equal to 5 Henry, and then capacitance C is equal to 80 microfarads, that is equal to, micro means 10 to the power of minus 6 farads, and R is equal to 40 ohms. Then number 1, the resonant frequency omega R is equal to 1 by root LC, that is equal to 1 by under root L means 5, C means 80 into 10 to the power of minus 6. 80 into 10 to the power of minus 6. So how to calculate it? It is simple. So that is equal to 1 divided by 5 8s are 40, you know, 400 into 10 to the power of minus 6. Bring 10 to the power of minus 6 out of root, that is 10 to the power of minus 3 under root 400. 10 to the power of minus 3, when it goes up, 10 to the power of plus 3 by under root 400. 4 and under root 400 is nothing but 20, that is 1000 divided by 20, and you will get 50 radians per second. 50 radians per second. So the first part is over, and now let's see the second part. What is the second part? What is the second part they have asked? Let's go and see. The second part they have asked the current at resonant frequency. Current at resonant frequency they asked us. So let's go and calculate now. So now current at resonant frequency. So at resonance, Z is equal to R already, which we talked about that. And then see, so here we have seen at resonance, when I was explaining this, at resonance, here I told you like maximum current flows through the circuit when at resonance what happens, XL is equal to XC, then maximum current flows through the circuit. Here I have explained that time this is Z is equal to R. Z is equal to R. This is at resonance. Okay, so this is, I already told you this when I was talking. If better if I write here at resonance, it will be useful for you. Resonance, at resonance. So Z is equal to R. So let's continue with that second part. At resonance, Z is equal to R. Then when Z is equal to R, that is nothing but, that is R is equal to 40 ohms they have given in the problem. Then RMS value is equal to VRMS by Z, that is 240 by 40. VRMS is given in the problem and 40 is the resistance. Then you will get, that is 6 amps. Second part is over. Now let's go for the third part. What is they asked in the third part? So in the third part they asked the RMS potential drop across the capacitor at resonance. RMS potential drop across the capacitor at resonance. So let's go for that. Potential drop, you know the simple Ohm's law. The simple Ohm's law says that V is equal to I into R. So in the similar way here, VRMS at capacitance, for the capacitance, is equal to IRMS into capacitive reactance is XC. So that it will become that is equal to IRMS, and XC is 1 by omega RC. So IRMS just now we calculated, we got a 6, and 1 by omega C. Omega value we got calculated 50, and then capacitance is 80 into 10 to the power of minus 6. 80 into 10 to the power of minus 6. Then after that let's continue. That is equal to 6 into 1 by, that is 550 into 80, 10 to the power of minus 6. If it goes up, it becomes a plus 6, and then simplify them, and after simplifying you will get 1500 volts. So this is the answer for the third part of this problem. So like this you have to solve. Then after that let's go for the last problem. Let us see the third problem which we have taken. So the third problem is, this is the third problem. They have given a radio can tune over the frequency range of a portion of medium wave broadcast band 800 kHz to 1200 kHz. If its LC circuit has an effective inductance of 200 microhenry, what must be the range of its variable capacitor? So what they have asked is, its frequency is changing. How its frequency is changing? It is changing from 800 to 1200 kilohertz. That means minimum frequency is 800 kilohertz, maximum is 1200 kilohertz. For that, L value is fixed 200 microhenry, and you have to find C value at 800 and C value at 1200 kilohertz respectively. So this is what the question. So this is generally used in the old radio sets, like old generation people know that. So whenever we are using a radio, we were using the radio olden days, we used to turn the knob to change the radio stations. To turn the radio this one knob, we turn the knob outside. Inside it is connected to a variable capacitor. The capacitor changes, therefore the frequency changes. When the frequency changes at a particular frequency, we get the desired radio station. So we used to hear the particular radio station in our childhood, but now this generation, I think you people don't know about radios because it is already out of scene, because most of the people are using mobiles and TVs only. Therefore, according to me, most of you don't know about the radio. But in our childhood, we used to listen to radio, radio music, radio news, radio cricket commentary and all. But in that knob we used to change, and inside that is connected to a variable capacitor. The variable capacitor can change its capacitance. Now that is what we have to calculate, from where to where the capacitor should have the frequency to have this particular broadband 800 kilohertz to 1200 kilohertz. Again the same formula, frequency formula, this one only we will use, which I have written here, in the red box and kept here. This formula only we will use. That's what I told you. If you learn the 4 to 5 formulas related to the topic, numericals are very, very easy. That is, I have been telling you that. So now let's go for that third problem. Now it's problem number 3. What they have given in the problem is, first they have given only inductance value 200 microhenry, and they have given frequency range. Let's say at first time f1 is equal to 800 kilohertz. Now f1 is equal to 1 by 2 by under root LC, that is 1 by 2 pi, that is 2 pi L value is, okay, let us write first LC only, then I will square it on both the sides for simplification. F square is equal to 1 by 4 pi square, root will go, you will get LC. Why I have done this is to simplify this, so to make the problem simplified, because when you square on both the sides, this under root LC, this one like under root LC will be cancelled and you will get square here. So that's why I have squared it on both the sides. So now what you can do is, now send this C to this side, and bring this F to this side. Now we will get C is equal to 1 by 4 pi square F1 square L. Now it is simple for you to calculate, nothing is difficult, all the values are given. So 1 by 4 pi square means 3.14 whole square. F1 first time frequency 800 kilohertz means 10 to the power of 3, that is whole square, and L, that is 200 microhenry, 10 to the power of minus 6. So if I calculate here in this YouTube, it takes quite a long time. So I am simplifying and giving you the answer. It comes around 197.8 into 10 to the power of minus 12 farad. 10 to the power of minus 12 we call it as pico. Therefore it is picofarads. Approximately we can write it as 198 picofarads. In the same way, use that same formula, this formula of C, and find the C value at F2. Find the C value at F2 now. So let's continue. Again, C is equal to same formula we are using. Now frequency is equal to 1200 kilohertz, that is other side. So 1 by 4 pi square. 4 pi square means 3.14 square into now 1200 kilohertz, that means 10 to the power of 3 whole square. Inductance is same, that is 200 into 10 to the power of minus 6 whole square. So now after simplifying everything, now you will get 87.9 into 10 to the power of minus 12 farads, that is approximately equal to 88 picofarads. So what is the final answer we have to give? The final answer we have to give is the capacitor can change its range. First it can have a value which we got here 198 to 88. So we can write it changes it from 88 picofarad to the other value is 198 picofarads. So this is our answer. So in this way we can calculate the problems. Now you have seen me how simple within a small limit of time we have calculated 3 problems. Yes or no? So we have done 3 problems within we didn't take much time to calculate them. So only thing is what is the simple way to calculate is we should know the related formulas, all the related formulas, then proceed first writing the given data and then taking the related formula, try to calculate them and solve the problems. It is simple, it is not much difficult like as the children are afraid of. In fact, numericals are easy to solve. All the best for your exams, and whatever may be the exam, it can be a board exam or JEE mains or NEET or any competitive exam. Get ready by solving the numericals in a simple way. Let's meet with some other numericals in the next video. Until then, bye. God bless you all.